present an environmentally useful and practical idea, converting walnut shells into biofuel fuel that can be used in thermal power plants or produced in small-scale community units. Walnut processing creates large amounts of hard shells that are often discarded or burned, wasting a valuable energy resource. By collecting and processing these shells, we can create a clean, energy-dense solid fuel that reduces waste, lowers dependence on fossil coal, and provides income for local producers. The process begins with collecting and drying the shells until their moisture is low. We then crush them into a uniform powder and subject them into controlled thermal treatment. There are two main thermal routes: torrefaction, a mild heating step around 200 to 300 degrees Celsius that makes the material brittle, higher in energy density and water resistant, and excellent feedback for repellents, and slow pyrolysis, where shells are heated in a low oxygen environment to produce biocoal or charcoal with stable combustion properties. After the thermal stage, the powder is formed into briquettes or pellets using a press and a small grinder such as starch or a natural adhesive. These briquettes are then dried and cooled for storage. On a small scale, simple drum retors, manual briquette presses can make this technology accessible to villages and small industries. All you need is a metal retort for carbonization, a grinder, and a hand or mechanical press. The resulting fuel has good calorific behavior and handles like a coal, but because it is made from biomass, it is renewable and can dramatically reduce the amount of waste burnt into fields. For industrial use, biocoal or torrefied pellets can be co-fired with coal in thermal power plants after quality testing and appropriate blending. This helps lower net fossil carbon use and can be integrated into existing systems with proper control for ash and emissions. There are added advantages in some pyrolysis process, and volatile condensates can be collected as bio-oil, creating another revenue system, and the heat from the conversion process can be reused to dry incoming shells. Improving energy efficiency, safety, and quality testing are important. We must check moisture, ash, and stability and avoid open burning. Small producers should follow safe and handling rules and use simple emissions control where smoke could be a problem. In conclusions, transforming walnut shells into biocoal and briquettes presents a low-cost, scalable, and sustainable solution. It turns agricultural waste into valuable fuel, supports local livelihoods by enabling small-scale production, and helps reduce reliance on fossil fuels when used responsibly in thermal plants or community burners. This idea demonstrates how circular thinking and simpler technology can make energy production cleaner and more local, benefiting the environmental and communities alike. Thank you.